I'm Andy Davis. I've been Research Director for NCC Group for almost 4 years now, and plenty of years within the industry. But even though I've got the title of Research Director, I'm still a very hands-on, very technical kind of guy, and I like testing more kind of unusual technologies. If you've seen any of my previous talks, I've done quite a lot of work looking at security of interfaces like USB, and yeah, I like focusing on things that people find quite tricky to test by looking at them initially. So yeah, like developing tools to test this kind of stuff. So Zulu, that I'm going to talk to you about today, is a tool that I wrote internally within NCC Group about 1.5 years ago. We've been using it as a private tool on client engagements for that time. And it's kind of got to the stage where we feel that we've got the kind of commercial benefit internally from it, and I'm prepared to share it with the rest of the community so everyone can play with it, because we've kind of refined it over that time and feel that it's now kind of ready for prime time, ready for everyone else to have a play with. It's written in Python, more specifically WX Python, that gives you the GUI element to it, and it is as much as possible input and output agnostic. So it's kind of modular in nature. You can apply different types of input to it, mutate that input, and then apply it to anything you like, really. And even though from its kind of initial development, it's always intended to be a GUI tool, if you want to add additional complexity to it, there is functionality to do that via something called Zulu script that I'll talk about later on in the talk. So I'm sure some of you are thinking, oh, another fuzzing tool. There's hundreds of fuzzing tools out there, some specific to protocols, some fuzzing frameworks. Can I get a quick show of hands? How many people in the room have used a fuzzer? Any kind of fuzzer? Okay, good. And how many people have written any kind of fuzzer, even if it's just like a little Python script or Perl script? Cool. Okay, good. The motivation behind this was a lot of people need to do fuzzing, sometimes on client engagements, and they need to be able to set up a fuzzer quickly and easily to demonstrate something. And although there are some very good fuzzing frameworks out there, quite often they have a steep learning curve, and if you're restricted on time, it can be prohibitive in actually using those to get useful quick output and get a kind of a general feel for what the likely outcomes of fuzzing are going to be with the specific thing that you're testing. So I thought, you know, why not take the model that's used for web-based proxies, like Burp, for example, that are commonly used to test web applications, and apply that model to a fuzzer that will allow you to fuzz both text-based protocols, but also binary protocols as well. So it's literally a kind of a drag and drop, point and click, rapid prototyping capability of getting a fuzzer up and running. With the added extra complexity that's there if you need it once you've demonstrated what you're trying to achieve. So, basics of the GUI, you have this input area, the mutations that you've decided to apply, the kind of fuzz cases that you've decided to apply to data, a choice of all these different mutators. You can then see the bytes within the data that you've captured in hex and ASCII, and then the status of the tool. So I must stress this is a mutation-based fuzzer, so the whole point is you use some kind of legitimate client that's talking to a server, not necessarily networks, but it was initially written as a network fuzzer, and we'll talk about some of the other things that it is capable of fuzzing later on. But so you're using a legitimate client and server, capturing the data, and then in an automated fashion, replaying that in a mutated sense, in a kind of a structured way to try and find vulnerabilities. So here's a quick screenshot of some actual data in there to show you what it actually looks like. But the way that I've written this is kind of along the lines of the accompanying white paper that you can download, which is a series of tutorials that will show you how to use the fuzzer in lots of different scenarios. So if you want to use the tool, you can download it and download that white paper, and it will kind of explain in more detail what I'm covering within this talk. There's a simple console associated with it that shows all the data for each of the fuzz cases. I won't spend much time talking about the file structure. It's more for completeness, really. So I'll move on from that side. So the initial capability I wanted to develop was a proxy-based network fuzzing module. So the ability to use any kind of network client talking to a server, capture that data, regardless of whether it's text-based or whether it's binary, and mutate that data in an automated fashion. So first of all, you go to proxy settings, and you can configure the target host where your server is connected. Set up a local port, just like with a kind of a web-based proxy that you would use. Start the network capture, and it's ready to use. You can then start communicating using your client talking to the server. So in this instance, I'm using remote desktop. So I've configured it to talk directly to the proxy, and you can see as it's capturing the packets, those packets are displayed in real time within the tool. You can then stop that network capture and start manipulating the data in those packets. Originally, I was planning on doing some kind of live demos with this, but when I actually tried doing some of those, it's not really particularly exciting watching a fuzzer running. So I think it would probably make more sense to just talk through the screenshots as I'm doing that. So that's why I'm doing it in that sense. But hopefully, because I'm going through in a kind of step-by-step fashion, you'll be able to easily replicate that when you download the tool yourself. So as you can see, there are our packets that we've captured. The ones that are highlighted in light blue are the ones that you're able to manipulate, because currently the tool will only fuzz from client to server. It doesn't fuzz in the other direction. You can't fuzz the client from the server. Hopefully it will have that capability in the future, but at the moment you can just fuzz servers. So the packets highlighted in dark blue is the current one that you're looking at. And what I've shown as an example here is quite often if you've got a whole series of packets within a TCP stream, there may be several that you want to send as is before the packet that you want to manipulate with various fuzz cases. So just showing there, you can select the send data unmodified. It turns that top packet green. And selecting the next packet, we then decide we want to add a fuzz point. So it's literally just a case of highlighting the data within the field down there, right-clicking and saying, I want to add a fuzz point. Again, trying to make this thing as quick and easy to use as possible. There's a whole bunch of mutators in there, and they're taken from the open source FuzzDB. We've actually augmented the FuzzDB with some of our own. But yeah, you literally just click on the checkboxes for the ones that you want to incorporate within your fuzz run. And you can see next to some of these, the text-based ones, there's a little icon. If you click on that, it will spawn a notepad with the list of mutators within that particular class of mutator to allow you to edit that and modify your own, or just see what's in there at the moment. So once you've selected your mutators, you need to choose the output method. So in this case, a network fuzzer. And if you just want to use the target that you captured from, the information will be automatically populated within there. And there's a few little things that you can change in there, like connect retries, timeout, that kind of thing. And there is the ability to select UDP if you want to fuzz UDP rather than TCP. And you can see that once the fuzz case has been selected, that the bytes associated with that turn orange. So we can now start fuzzing. and it goes off and you get all the output within your fuzzing window, and it gets logged within a file as well for each session. So hopefully you get a case where you've identified a vulnerability and the target crashes, as it shows there. So what happens there is you get a nice orange icon highlighted, another orange warning triangle there saying that the service that you were fuzzing has stopped responding, and therefore this may be a crash case. Now, any of those of you who've used fuzzers in the past will know that sometimes you get false positives. So you get situations where the connecting service or the connecting fuzzer thinks that the service has crashed, but maybe it's just being really slow, and as a result, it takes longer for the response to come back. So instead of stopping the fuzz run at the point where it thinks a crash has happened, it just pauses it. So if you go and check and see that the service is actually still running, you can just hit the play button and it will continue from where it left off. And that's something that I kind of added as a result of tweaking with the tool, because it was very frustrating if you had a false positive after it had been fuzzing for an hour and you then had to start fuzzing from the very beginning again. And another really cool thing here is, again, people who've used fuzzers in the past, you let it do its fuzz run, it finds what it thinks may be a vulnerability, you've done something that generates a crash in the target service, but then the hard part is trying to track down what that packet was that generated the crash. What Zulu does is it makes the assumption that the previous test case before the time that the service stopped responding is the one that generated the crash. Now, that may be an incorrect assumption. There's some bugs that need like a combination of different data in order to result in the crash, but I'd say more often than not, it's the test case that gets sent that stops the target responding. So what it does is it takes that test case, it creates automatically a proof of concept exploit to demonstrate that crash in Python. And if you've got the email settings set up properly, which I'll show you how to do a bit later, it will send you an email, and the proof of concept will be there as an attachment in your inbox. So there's none of this going through the log files and trying to find out, how it crashed and why it crashed, and then trying to work out how to create your own proof of concept. It does all that for you, and it emails it to you. So not only do you get informed that your fuzzer has found a bug, it also says, and you run this Python script, and it will replicate that bug. So maybe you've got PCAP files associated with sessions from previous communication between a client and a server, and you just want to use that PCAP file as the input to your fuzz session rather than actively sitting in between the client and the server. So you can do that. I'm sure you've all used Wireshark. You can capture your PCAP session in Wireshark and make sure that you do follow TCP stream. So you're only fuzzing the TCP stream associated with the traffic that you're interested in looking at. And you can select import PCAP. And as you can see there, it's displaying all the data as it would if you'd just done a proxy-based capture that I've just described. Although there's slightly more information in there. Because it's come from a PCAP file, you've also got some of the TCP control packet information, so SYNs, ACKs, FINs, that kind of thing, which you can obviously ignore. And the tool ignores and copes with those as well. So now, the next capability I was asked to produce by some of the guys internally that were using this was file fuzzing module. Again, none of these things so far are capabilities that you can't download from individual tools. There's plenty of file fuzzers out there. There's plenty of network fuzzers out there. But what I wanted to do was apply this very kind of intuitive, interactive, easy fuzzing environment to the different capabilities, so that once you were used to using Zulu, you could just say, right, I want to fuzz a file now, rather than fuzzing a network service. So it's literally just a case of importing a file. selecting a process that you'd like to apply that file to. So, what file do you want, or what application do you want to open this file that you're mutating? You can give it a lot of command line arguments if they're needed. Tell it how long to actually run for before killing each process, because obviously if you're spawning this application multiple times with different mutated files, some of these applications take a long time to load up. For example, if you're going to open and close Microsoft Office each time, it's going to take a lot longer to do than if you're opening Calculator or whatever. So it allows you to configure that kind of stuff. And there's various different shutdown methods that you can use, because some are more successful than others depending on the application that you're testing. And yeah, so we've chosen the process there, and there's an inbuilt debugger within there, so that if the process crashes as a result of the file that's been applied to it by Zulu, it will do some kind of initial triage on that and tell you the address that the application has crashed at, to give you an indication of the class of bug. I mentioned at the beginning I've done quite a lot of USB research in the past, so an obvious choice for me was adding a USB fuzzing module. One of the issues with this is it does relate to a specific application tied to a specific USB analyzer device, which just happened to be the one that I had and I've used quite a lot. So if you haven't got that particular analyzer, this tool isn't the one for fuzzing USB, but there's other USB tools that I've written, like a tool called UMAP if you wanted to download that. But I thought I'd incorporate it because it's something that I could do. So graphic USB, this is just the GUI that controls the USB analyzer that I've got. And you tell Zulu that you want to import a USB generator script. Because with graphic USB, what it allows you to do is it allows you to capture a session from plugging in a device all the way through to enumerating it and communicating with class-specific communication, and you can then create a generator script that emulates that effectively. So what we're doing is the way that we're fuzzing the data is we're manipulating that generator script for each test case. So after you've created your generator script within graphic USB, that's what you import, and again, it just displays it as packets of data. And the way that the instrumentation is done with USB is because normally when you get a USB crash, it's a kernel panic or a blue screen, that kind of thing. So a quick and easy way is just using ICMP. So if you give it the IP address of the device, make sure it's connected to the same network, then if it stops responding over the network, then there's a good chance that it's rebooted as a result of a kernel panic. And there's the fuzzer running. It automatically spawns the application and controls it from within Zulu. And there's a serial module. Again, this was a result of a specific engagement that we had where one of the guys was looking for Haze AT command set vulnerabilities associated with a mobile device. So he said, yeah, wouldn't it be cool if we could use Zulu to do the fuzzing of the AT command set over the serial? So again, you've got input method there. You can choose serial data capture, set up your port settings, and you're sitting in the middle of the serial session. So you can specify a number of AT commands that you wanted to fuzz. For example, here we're just sending ATI1. Because serial's asynchronous, I had to think carefully about how I was going to represent this data within Zulu, because technically what I should be doing is a separate line for each byte that was being sent, but came to the conclusion that in most cases your serial data is actually kind of interspersed with carriage return line feeds. So use the carriage return line feed to kind of delineate between what I've essentially called packets. They're not packets because it's asynchronous data, but it's a good way to represent it within the fuzzing tool. It's quite intuitive and easy to see, so that's what it does. So you can see, for example, this packet here has got the ATI1 command. And then you choose the output method, serial fuzzer, and again, the serial fuzzer communication. And as I showed with the USB stuff, it's using ICMP again for instrumentation, because this is low-level stuff that will probably result again in a kernel panic if you find a bug. Wireshark integration. I've talked about Wireshark a bit earlier, about generating PCAPs and inputting those PCAP files. But we thought it'd be really cool if, when you're capturing data between a client and a server and you don't really understand the format of that data, we could leverage the use of the Wireshark's capability to dissect that data and interpret it. So what you do is tell it to turn on Wireshark integration, point it at where Wireshark is, and when you've captured some data between your client and your server, it will automatically generate a PCAP file that corresponds to the data that you've just captured, and will automatically load that into Wireshark. So Wireshark's dissectors will then interpret the data for you, and you can start seeing which portions within that data would be appropriate to then start fuzzing. VMware integration. Another useful feature that I thought would be good would be if most of the time when you're fuzzing a process, maybe a network service, you're going to be fuzzing it within a VM rather than on your physical box. Certainly not on the physical box that the fuzzer's running on, because if you end up blue screening it, then you've got no idea how it crashed. So chances are your target will be running in a VM. And in some circumstances, you may want the VM to be restarted as a result of a crash, because the type of crashes that you see might not reboot the service, or might not reboot the device, but it might crash it into a state that needs to be restarted. And again, with the process, you may have a crash that occurs that needs the process to be started because it doesn't auto restart itself. So with VMware integration, you add all the appropriate information. You choose whether you want it to restart the whole VM or just restart a process within that VM. And then whenever a crash occurs, obviously it will notify you in the same way that I mentioned before with email example. But it will take care of doing all the rebooting in an automated fashion. So if your fuzz run is going to last overnight, you don't want to wake up in the morning and find out that it crashed 10 minutes after you went to bed, and then it's just been sat there hanging, waiting to be rebooted. One example of how the GUI is useful, for example, within a binary protocol here, let's say you want the first 4 bytes to be, or the first 4 bytes of the data that you've captured represent a length field, and that length field is the data within the remainder of the packet. A lot of the fuzz cases that are specified within the mutators are variable length. So you need to fix up that length field in an automated way for every fuzz case. Otherwise, the chances are it's not actually going to get processed by the target system. So here, you can highlight the bytes that represent that length field, right-click, add length field, and then choose whether it's big endian or little endian, and then highlight the bytes that are associated with calculating that length field, and it will do it all automatically for you, which is really, really helpful. I mentioned email alerts. So yeah, you just stick your email notification settings in there, and every time a crash condition occurs, you'll get a nice email with the proof of concept code in your inbox. So I'm hoping that people are going to use this because it's really easy and it's very kind of rapid to get a fuzzing session up and going. If you're not used to using fuzzers, certainly the more complex fuzzing frameworks. But I'm also hoping that once people have got the hang of using the kind of simplistic GUI element to it, they'll want to augment it with Zulu script, which is adding functionality to the processing of the data kind of in between the point where you're looking at the fuzz case that you've captured, or the data that you've captured, you've modified that in some way by the mutator, but before it sends it to the fuzzer, or the other side of that data, you can perform other actions, which can be pretty powerful. So, yeah, so after the mutator, but before being processed by the target. There's a special file in there, custom.py. It's Zulu script is nothing special, it's just Python. But there's a whole bunch of data that's exposed to you related to the packet and related to the session that enable you to perform this kind of processing. So examples of when you might want to use this, let's say you need to perform some kind of authentication each time you connect to a service, and you need to run some kind of third-party authentication library in order to do that. This is the point where you could do that. Or let's say you needed to do, you needed to base 64 the data that you've produced before you add it into the packet and send it on. Again, this is the kind of place that you do that. And just as a simple sample within there, there's a function for updating a content length field within an HTTP request so that you can see how to construct one of these additional Zulu script files. And it's literally just a case of clicking the Enable Zulu script checkbox and adding whatever data you want into custom.py. So these are the kinds of pieces of information that are exposed to you within Zulu script so that you can use that information to construct your Zulu script file. So I said that we've had Zulu for a year and a half now. We've used it on quite a lot of research projects internally and also on client engagements, and it's found tons and tons of bugs. A few of those have been reported and fixed, and advisor is released. There's a smattering of examples here. There's a whole bunch more that haven't either haven't been fixed properly yet, or we're still in discussion with the vendor about them. But as you can see, it's a pretty powerful tool, even though when you look at it, it seems quite simplistic in the way that you can use it. So simple doesn't necessarily mean that it's not powerful. So hopefully you're all going to go and download it and have a play with it. It's available today. It's on our GitHub website. And there's a whole bunch of other NCC Group tools on the GitHub website as well. So please go there, download it, have fun. If you've got any kind of requests or any bug fixes, anything like that, please get in touch and let me know. Thank you very much.